In this video, we'll explore heart disease through data analysis, offering valuable insights into this widespread health issue. While our findings may not be groundbreaking, they deepen our understanding of heart disease. Using graphs and stats, we'll uncover patterns in the data. Heart disease covers various heart problems and is a major cause of early death, especially in developed countries. Keeping the heart and blood vessels healthy is crucial for overall health, with obesity, inactivity, and smoking being key factors according to experts. Our journey begins with a deep dive into the factors contributing to heart disease risk. Join us as we uncover insights shedding light on this important health issue. Our dataset collected in the USA in 2020 with approximately 319K observation, and it explores the impact of different factors on heart disease. While it includes individuals from various ethnic backgrounds within the US, the majority are white. Our data centers around heart disease status with 17 other parameters categorized as demographics, clinical measures, and lifestyle choices. The data includes numeric variables, yes-no indicators, and predefined categories. Our initial analysis revealed a near 50-50 split between men and women. However, the data leans heavily towards healthy individuals, potentially biasing our results and limiting their generalizability. Before diving in, we checked for missing values and used box plots to handle outliers, opting not to delete any due to our dataset's large and robust nature. We used label encoding for categorical variables in correlation matrices and tests. Some variables were grouped for clearer visualization. An 80-20 split created training and testing sets for model development. Through our study, we explored heart disease through five key questions. We looked at different risk factors and how they work together, even building models to predict the impact. To answer research question number one, we examined how physical activity, sleep time, and BMI influence heart disease risk. Using a t-test, we found a significant BMI difference between heart groups, with the heart disease group having a higher BMI. Sleep time also differed significantly, with most people sleeping 7 to 8 hours. Initially, physical activity seemed higher in the heart disease group, but our frequency test revealed a 15.5% higher frequency in the healthy group, opposing the initial findings due to a data bias. We used logistic regression to examine smoking, alcohol consumption, and heart disease risk, finding all the parameters significantly related to heart disease. Smokers had 2.25 times higher risk of heart disease, while drinkers showed a slightly lower risk. Although the model's accuracy of 64% may not be high, it provides valuable insights into the combined impact of these risk factors on heart disease. To explore how demographics influence heart disease risk, we analyzed age, sex, and other factors. Descriptive stats revealed older individuals in the heart disease group. Logistic regression confirmed significant predictors for both age and sex, with sex having a stronger association. The model achieved 77% accuracy. And now, to understand the link between various health conditions and heart disease, we conducted again logistic regression, which confirmed the significance of all the conditions to heart disease, with stroke having the highest impact, followed by kidney disease and diabetes. The baseline heart disease odds were low. Confidence intervals were calculated at 95% confidence level. The model achieved 76% accuracy. To understand the impact of physical and mental health, as well as difficulty walking on heart disease risk, we conducted logistic regression. Baseline heart disease odds were low. Mental health had a slight negative effect. physical health a minor positive 1, while difficulty walking significantly increased heart disease odds. All predictors were highly significant with 95% confidence interval. The model achieved 82% accuracy. Overall, difficulty walking emerged as strong predictor, while mental and physical health had smaller roles. We categorized our dashboard into clinical insights, demographic segmentation, and health behavior and well-being, plotting correlation matrices for each. These visualizations provide insights into risk parameter connections and dataset prevalences. Let's start with the BMI. We crafted a group bar chart complete with error bars and categories aligned with health industry standards. The partition key on the lower right clarifies these categories. This graph not only shows prevalence percentages but also includes a table in the upper right detailing these percentages and the deltas between sick and healthy groups. Interestingly, the data reveals a nonlinear relationship between weight and heart disease. According to studies, this is indeed true. The highest delta is seen in the obese class 1. The consistently small SE values indicate reliable BMI prevalence estimates across heart disease categories. The health conditions odds ratio forest plot displays conditions on the y-axis and odds ratio on the x-axis. On the right, the table shows percentages and deltas between healthy and sick groups. Confidence intervals bars not crossing the dashed line indicating statistical significance. All odds ratios are above 1, indicating higher odds of heart disease associated with the presence of the predictor. This trend is also reflected in the positive deltas in the prevalence table. Stroke has the highest odds ratio, consistent with the shared risk factors between stroke and heart disease. To assess the relationship between mental health, physical health, and difficulty walking and heart disease, we used a forest plot to display odds ratios. The key table on the right categorizes these health aspects. All predictors are statistically significant, while mental and physical health have a minor effects on heart disease. Difficulty walking significantly increases the odds. Here in the chart showing prevalence percentages of heart patients by age and gender, we see a visual confirmation of our hypothesis that gender impacts heart disease risk. Both genders show similar heart disease distribution until the mid 50s. From then until around age 75, men face higher risk. After this age, the trend shifts in favor of women. To visualize lifestyle factors and how they affect heart health, we crafted a group bar chart displaying prevalences as percentages for both heart groups, complete with error bars. The table on the right details these percentages and the deltas between sick and healthy groups. From the prevalence table and the chart, we can learn that smoking emerged as a negative factor for heart health while physical activity shows a positive impact. Alcohol drinking is associated with heart disease, but with a smaller effect size compared to other factors. Sleep time was grouped into three categories: short, normal, and long. A top right table displays these, and the bottom right shows the test results favoring the yes group. Error bars highlight robust findings supporting our hypothesis on sleep's impact. Short sleep times show a higher sick percentages, likely due to sleep disorders. The patient group's frequency increases with long sleep times, possibly reducing physical activity crucial for heart health. Ultimately, our dashboard displays three correlation matrices for clinical measures: demographics, and lifestyle choices. Together with other dashboard components, it provides a comprehensive view of heart disease and its various risk factors. The matrices not only highlight correlations with heart disease but also among themselves, offering deeper insights to users. Let's summarize our findings. BMI and heart disease are not linearly correlated, with obese class 1 showing the highest prevalence. Short and higher sleep times show a higher sick percentages. Physical activity benefits heart health while smoking poses a risk and alcohol has a minor effect. Older age and male gender are associated with higher heart disease prevalence. Stroke has the most significant impact among other health conditions. And finally, we found that difficulty walking also significantly increases heart disease odds. Now, let's take a real case. Joe, a 65-year-old with a 32 BMI, he is a heavy smoker, lives a sedentary lifestyle, and sleeps only 4 hours per night. Given Joe's age and unhealthy habits, his risk for a heart disease is notably high. To mitigate this risk, we strongly recommend Joe achieve BMI below 18.5, quit smoking, adopt regular aerobic exercise, and aim for 7 to 8 hours of quality sleep each night. These lifestyle changes could significantly improve Joe's heart health. Here we have come to the end. This was our heart disease EDA study. Hope you enjoyed listening. Thanks.